This is a model answer for Skills Homework 3. And we have a little bit of stuff on variables and how we'd set out a table, and this is how you'd want to set out the table in the question in a moment. Read the account of this Benedict's test. What was Russell's independent variable, giving values and units? So the independent variable is the variable that I specify, I for independent, and we got here, decides to use an excessive Benedict solution, and he adds this to his test solutions, 0.2, 0.4, 0.6, 0.8 and 0.1 molar glucose. That's what he's specifying. So 1, the independent variable is the concentration. Molar is a unit of concentration, so it's concentration of glucose solution. So concentration of glucose solution. Give values in units. So the values they're using are 0.2 molar, 0.4 molar, 0.6 molar, 0.8 molar, and 1.0 molar, or mole per dm cubed. Question 2, what was the dependent variable? So it depends on the experiment, so it's the actual results that we are getting. And what is he actually doing? He's filtering to remove the precipitate and then weighing it. So anything that's weighed has a mass, so it's mass of the precipitate. So the dependent variable is the mass of precipitate. And the units, that is in grams. Question 3, list the controlled variables with their values and units. So we are looking for anything that we're going to keep the same. So for example, how high we are heating this solution to, the temperature of the solution, how long we are leaving it for, any volumes are a good idea. We've got a 5 there, we've got a 1 there, so we could list those. So for example, temperature for heating, for heating 80 degrees C, time for heating 2 minutes, volume of test solution 1 cm cubed, test solution 1 cm cubed, volume of Benedict solution, so volume of Benedict solution, that's 5 cm cubed. Oh, we've changed that to 5 minutes there. It was 2 minutes. 5, that's actually 5 minutes there now. But you get the idea, these are all controlled variables. Controlled, ED on the end, because we are controlling these. These were controlled in the experiment. Is the data continuous or discrete? Well, we're actually measuring something from a weighing balance, and that could give us any number at all. So it's actually going to be continuous there. So is the data continuous or discrete? It's continuous. And let's get this data into a suitable table. So the design of the table is going to be something like that. I'll do a really rough one just to build it up first of all, but we can think of any results table is basically a box, and in this box we're going to have our independent variable on the left, and then just like we've separated off the left, we're going to separate off the top, and our top is going to be our dependent variable. So we've got independent on the left, and then on the right, labelled at the top, we've got our dependent variable. We would have a slash, it tells what the units are, a slash, it tells what the units are there. Our independent variable, well, we've got 1, 2, 3, 4, 5 things. So if I've got 5 things, I want 4 lines in here. 1, 2, 3, 4. So that's now my 5 things down there. How many repeats have we done? Trial 1, trial 2, trial 3, and we calculate a mean. So this is the tricky bit. This table title here wants to go over all of my trials. So I'm just going to put another line in here and separate this off into trial 1, trial 2, trial 3 and a mean. So I want four columns there. So if I divide that into 4, and this will be trial 1, 2, 3 and then my mean. Okay, so that's the style that we're going to do it in, and I'm just going to do the same thing but make it look a bit neater. So I'm just going to do it with the ruler. You don't have to measure the table, but if you're doing it with nice straight lines, it just makes it clearer to read. So I'm not going to measure anything. I'm just going to follow my same method again. I'm just going to have my independent variable here and my dependent variable up there. Okay. The name of my independent variable, well, this was our concentration of glucose solution. And my units are molar. Here's remember my dependent variable across there. So my dependent variable is mass of precipitate formed. So mass of precipitate formed, and the units there is grams. And that goes all the way across there. I have got 5 of my independent variable, and again, lined paper it's dead easy as this, but otherwise you can I'm just going to guess where the lines go here. So 1, 2, 3, 4, 5. And I'm going to put in my independent variable, my concentration of glucose solution. I've got 0.2, 0.4, 0.6, 0.8 and 1.0. A couple of things to notice here. I'm not putting the units in here because I've got them at the top. And this last one, 1.0, I'm using the same level of precision as with the other ones. I'm not just going to leave that as 1. And then we need to divide up our trials and mean. again without measuring, trial 1, trial 2, trial 3 and mean. I don't need to write the mass of precipitate because it's on top of them, and I don't need to write the units again because the units is on top of them. So these all belong to our dependent variable title there. So we're now going to write in our values. So in trial 1 we had 0.4, 0.4 is 0.9, so I'm going to change that to 0.9 there, 1.0, 1.7 and 1.9. Again, no units. They'll take marks from you. The units are there, we don't have to write them again. Trial 2, 0.5, 0.8, 1.2, 1.6, 2.0, trial 3, 0.4, 0.7, 1.1, 1.5 and 2.2. Right, in calculating our means, ideally we just express our mean to the same level of precision as we have with our data. If you do that, then it just makes it nice and straightforward. Nice simple rule to follow. Technically you can put it to 1 decimal place further, but we're not going to do that now. So all we're going to do is fire these into our calculator. 0.4 plus 0.5 plus 0.4 is 1.3, and divide that by 3 is 0.43. So 0.43, do I round that up or do I round that, keep it as it is? I'm just going to keep it as 0.4. Next one down, 0.9 plus 0.8 plus 0.7, 2.4 divided by 3 is 0.8. 4.6, 1.0 plus 1.2 plus 1.1 is 3.3 divided by 3 is 1.1. And you notice with my decimal places, they're all kind of on top of each other, makes it easier to read. Next level down, 1.7 plus 1.6 plus 1.5, divide that by 3 is 1.6. And the last row, 1.9 plus 2.0 plus 2.2 is 6.1 divided by 3 is 2.03. So we want 2.0, and do we need to round it up? No, because it's 0.3 after it, so it's 2.0. Nice and clear. All your tables should look a little bit like that.